Okay, welcome. So we are going to take a look at electric fields today, and so this is section 7.2, I believe, from the textbook. Okay, so electric fields, as I've said before, is very, very similar to gravitational fields, magnetic fields, etc., etc. Okay, and somebody asked me a question. I'm just going to say this again just to clarify it. When you have an object, for example, okay, like Earth, you have a gravitational field that exists around this object. The field just basically means an area around the object in which the gravitational force exists. So if I have an asteroid flying by that enters this field, what's going to happen to it? It's going to get attracted to the Earth, which means it's going to go down. Does that make sense? Does that make sense? This is what field means, right? So this is what we said, or we talked about, and we understand in terms of the field of gravitational field of Earth. We know it exists all around Earth, and it attracts objects when you enter this field. Now, electric field is exactly the same way. So instead of my Earth being a mass there, you can't say, does the field attract other things? No, the field's just there. If you come in this field, you will be attracted or repulsed. Okay? How some certain people do that too. Okay? You get close to them and you are attracted to them, and then some of them, they just want to run away. Okay. So now charges are exactly the same way. So if I have a positive charge, for example, my field is all around it. If I have another charge that is in this field, this charge, whether it's a positive or a negative, will cause an attraction, which means there'll be a force that will cause this secondary charge to either be attracted to the first charge or to be repulsed from that charge. So a field is just an area around my charge in which the force exists. Okay? I know a lot of people are having problems visualizing what field, what are we talking about? Okay? And now when we do these questions, we talked about the field. Here I'm drawing a picture which is a spherical picture. Okay? However, when we talk about fields and when we do calculation questions, we're talking about it in straight lines. Right? And you're thinking, oh, how does that work? Okay? Well, we don't have the background or the mathematical know-how to talk about 3 dimensions anyway. So we are going to talk about just uni and 2-dimensional objects only. Okay? Because that's what we do in grade 12. Okay. So electric fields, the question that we're going to do is the following. This is the question I want to do. So imagine I have 2 charges, Q1 and Q2, that are at the 2 ends of an equilateral triangle. Okay? And my sides are 10 centimeters on either side. So let's go do this question. I'm going to draw it out. So I've got Q1, Q2, and I have a positive test charge which is at the 3rd end. A positive test charge which is on the 3rd end of my equilateral triangle. So Q1, Q2, and test charge. Okay? Of course, this is 10 centimeters. This is 10 centimeters. And this right here is 10 centimeters. Okay? So, the first thing that we're going to take a look at is as follows. So the first thing we're going to do is we're going to draw out our epsilon vectors. Okay? And so if this is my Q2, both of these are positive charges, and the charge for this is, or the value for this charge is 1.0 times 10 to the negative 9 coulombs and 1.0 times 10 to the negative 9 coulombs. Okay? So here, the first one right here, this epsilon is coming out this way. This is E2. This is the straight line going out. Okay? And this right here is E1. Okay? So how do I figure out what my E net is? What is my net electric field at this point because of these two charges? Electric field. Okay, so what I'm going to do is, because it's a vector, so E1 plus E2, which gives me E net. Okay, and of course I'm going to draw it in terms of vectors. So you're going to have E1x, E1y, E2x, and E2y. Okay. Now, of course, inside right here, this was 60, 60, and this was 60 as well. Okay. So this right here, these two, what are they going to be? What are those two? Okay. And this right here is 60 as well. Yes. What are you talking about? Inside? This? I don't know, you tell me. You did math. Okay. Okay, yes. 120. Okay, 240, 360. It's supposed to be 360 degrees a circle, right? Yeah, it's not 60 all the way through. Okay, anyway, so 120, 120, 60, 60. Okay, all right, so let's go solve for it. The first thing we're going to do is we're going to solve for E1, which equals to E2, because they're both exactly the same. And that's going to be KQ over R squared. Okay, and that is 9.0 times 10 to the 9 times 1.0 times 10 to the negative 9 divided by 0.10 squared. So what is your E1 slash E2? What do you get? What is E1? What is my answer right here? What do you get? 900. 900. By the way, I forgot to mention this yesterday, that epsilon does not have its own value. It's newtons per coulomb. Newtons per coulomb. Okay. All right. We're not done, anywhere close to done. So what we're going to do now is we're going to say E net x. Okay. And that's going to be E net x, which is 900, okay, times the cos of 60, okay, that is going west, plus 900 times the cos of 60, that is going east, and you end up with E net x, which equals to, what is it going to be? But that's not what we're looking at. Are we looking at that angle? It's a vector. You know how to do vectors. We've done this in chapter 1. Okay. All right, what is this again? It's going to be 0. Yes, they cancel each other out. My x components cancel each other out. Look at it. They're exactly the same value, so therefore this and this will cancel each other out. Okay? However, now that's what we're going to do our y. So our y is going to be E net y, which is going to be 900. The sine of 60 going north, plus 900 sine of 60 also going north. Both of these are north. Y is going north, Y going north. And what is your E net Y? Say that again. 1558.8 newtons per coulomb going north. Now remember, your electric field is a vector. Answer, yeah, is right there. Okay, electric force, electric field. Are we good? Okay. Questions? Yes. Yep. Yes. So this right here, this is just the vectors that are coming out of it. But I'm going to now add them together. So my angles are not the, I'm not going to use 120, of course, right? I'm just going to use this vector. It's just a vector. I'm just adding that to that and getting this. And these are my components right here. Okay? Yeah, we're not using these angles for sure. Absolutely not. Okay,